Hello, in today's video, I'll be solving questions from A2 Chemical Energetics from May-June 2019, paper 4-1. Question 6. A. Complete the table by placing one tick in each row to indicate the sign of each type of energy change under standard conditions. Bond energy is always positive as it is the energy absorbed to break bonds. Enthalpy change of formation is either negative or positive. B. Explain what is meant by the term enthalpy change of atomization. It is the enthalpy change when one mole of a gaseous atom is formed from its elements under standard conditions. C. The overall reaction for the atomization of liquid bromine molecules, Br2 liquid, is shown. Br2 liquid to 2Br gas. This happens via a two-step process. Construct a label energy cycle to represent this atomization process, including state symbols. And use your energy cycle and relevant data from the data booklet to calculate the enthalpy change of vaporization of Br2 liquid. The enthalpy change of atomization of bromine is plus 112 kilojoules per mole. So the first equation to write is the equation given in the question, Br2 liquid to 2Br gas. Now we are supposed to calculate the enthalpy change of vaporization. So that means that we have to heat the bromine liquid till it goes to the gaseous state. So which means we are vaporizing the Br2 liquid. And so we can convert the Br2 liquid to Br2 gas. And so from here to here is the enthalpy change of vaporization. Now we need to complete this energy cycle. So we can see that from Br2 gas to 2Br gas is bond energy. So we have broken the Br2 into Br atoms, 2 moles of Br atoms. Now on this first arrow, that is the enthalpy change of atomization. However, the enthalpy change of atomization is defined as the enthalpy change when one mole of a gaseous atom is formed from its element under standard condition. But here we are dealing with 2 moles of gaseous atoms formed. So it means that you have to multiply this enthalpy change of atomization with 2. To write the equation from this energy cycle, we can see that the arrow is going this way, then that way, but the top one became the opposing one. So which means that to write this equation, we have 2 times the standard enthalpy change of atomization is equal to the sum of the enthalpy change of vaporization plus the bond energy of Br2. This means that the enthalpy change of vaporization is equal to 2 times the standard enthalpy change of atomization minus the bond energy. The enthalpy change of atomization from the question is 112 kilojoules per mole, and the bond energy from the data booklet is 193 kilojoules per mole. Therefore, the standard enthalpy change of vaporization is 31 kilojoules per mole. D. Suggests how the standard enthalpy change of vaporization of iodine would compare to that of bromine. Explain your answer. The enthalpy change of vaporization is actually the energy required to heat the I2 liquid or the Br2 liquid, so the gaseous state. And this is dependent on the strength of the forces within these molecules. Now for I2 liquid and Br2 liquid, they have weak van der Waals forces. And the specific type of van der Waals forces is instantaneous dipole induced dipole interaction, that is ID interaction. Since I2 has more electrons than Br2, it means that I2 is going to have a stronger ID-ID interaction. So which means that you need more energy to be able to vaporize the I2. So we have to say the standard enthalpy change of vaporization of I2 liquid is more endothermic than Br2 liquid, as it has stronger van der Waals into bracket ID-ID interaction than Br2 liquid. I. Explain what is meant by the term enthalpy change of hydration. It is the enthalpy change of when 1 mole of a specified gaseous ion dissolves in sufficient amount of water to form a very dilute solution. For example, if you have Br minus gaseous dissolving in water, it becomes Br minus aqueous. And if you have sufficient amounts of water, then this conversion or enthalpy change is standard enthalpy change of hydration. II. Suggest why the enthalpy change of hydration of Br minus gas is more exothermic than that of I minus gas. Bromine and iodine are in the same group, group 7. And if you check the sizes or the ionic sizes, you realize that since iodine is at the bottom, it will have a bigger ionic radius than bromine. And both bromine and iodine gains 1 electron to form a minus charge. So which means that they both have -1 charge on them. And you can see that since this one has a smaller size, the charge density is going to be higher on this smaller radius. But for iodine, it has a bigger size, so the charge density is going to be very, very less on the iodine, which therefore means that the ion dipole interaction between the Br minus ion and water is going to be a stronger interaction, and so more exothermic than that of I minus. So we say that Br minus gas has a smaller ionic radius and a higher charge density than I minus gas. Hence, there is a greater ion dipole interaction between Br minus gas and water. Thank you for watching and see you in the next tutorial.